swipes going down and things like that. Yeah, I know there's been a lot of teachers sick this week. Everybody and their brothers getting, I don't know what stealth, was it stealth Omicron now? I think that's this week. It's not even just Omicron, it's stealth. And stealth means it's not, I guess it's not showing up as easily on tests. Who even knows anymore? You had the stealth. No, see, you don't have stealth, you have no symptoms, it doesn't show up in tests, so I think you're just fine. But you have stealth Omicron. is what it comes down to.
You could either have a false positive test or you have stealth Omicron. You would never.
No, you'd have a false negative. It won't pick it up, apparently. Yeah. So, something along those lines. So I don't know. I guess we just all have to play the game one way or another. Okay. We started writing objects last time, didn't we? Okay, so let me connect a few, and we didn't have any homework for today, right? I didn't quite get where I needed to be. Let's go back to main. So right off the bat, I want to bring something to your attention. So last time I kind of showed you what if we were talking about static versus non-static, right? Last class. And when we look at the documentation and we see a method defined as a static method, how do we call it? Call it using the name of the class in which the method was defined. If it's a non-static method, how do we call it? We call it using an instance of the class in which the method was defined. So in this case, we're writing our own class, string helper, and I wrote a non-static method in here. So this is a method that does not have the keyword static out front, which means that it is an instance method or a non-static method. How do we call instance methods? Using an instance of the class in which the method was defined. So this method was defined inside of a class called string helper. So we're going to need to create a couple of instances of string helper in order to call those instance methods. Make some sense? As opposed to, I can come into here and I could say static, forget about the public thing for now, it's not necessary in our current example. I can say static void do something. We'll have it take no parameters and we'll just do a system.out.println do something like that. Oh, quick plug. I think it was Emily who posted the CS club, whatever. They posted their study group hours or whatever, I think in general chat. So I think they're usually meet in this room. So if you want to come to those to work on computer science homework or really homework in any class, those are upper division computer science folks who can certainly help you with programming stuff or whatever, and they're more than willing to do it. So take a look at Slack and see what the times are for that and encourage you to participate. Or if you're working in a study group in here, meet during those times in there so that if you run into a problem, you can ask one of the upperclassmen for some assistance. All right, so in any case, I'm writing a method here just called do something. It's going to take 0 parameters and it's going to return nothing, and I made it static. Forget about why I made it static for a minute, but I made it static. Now, first of all, just to kind of drive this point home, I'm writing this class called string helper, and this guy is now filled with static and non-static methods. It's got both kinds, okay? So if I wanted to call his non-static method, I would call this using the class name itself, or the static method, I call it using the class name itself. How do we call static methods or class methods? We call them using the name of the class in which the method was defined. So I'd come out here and I would say string helper dot do something. I wouldn't use one of the instances. Now, realistically, I think we'd probably find, let's see if it works the other way with Java. Yeah, it did. So Java will figure out what you meant to do, and we'll call the static method from a non-static context. I would say this is bad programming. The reality is it was a class method, so we're going to call it with the class name, versus it's an instance method, so we'll call it with the instance of the class. Go ahead.
You can't just do something that
That's actually a good question here. So previously, when we wrote static methods in here, when we wrote them inside of this class, so we'll call this guy, we'll say static do something else. System.out.println do something else. This is going to be void. So sticking with what I've been saying already, this is a static method. So we call it using the name of the class in which it was defined, which is called main. So we would say main dot do something else. All right, so now both of these guys will work. So there's our do something else. Now, what you're saying is before, oh, we were allowed to do this. It was working initially, right? Like, oh, do something else, no problem. I'll go and run that. And there it is. But what if I took string helper off? Screams at me and says, I don't know anything about this guy. Why? This comes down to what is our context? What's our current context? If I am inside of a class method, inside of the main class, my current context, the world in which I live, is in the static world inside of main. So I should have access to everything that is either a local variable in this method or things that also live in the static context of main. Do something else lives in the static context of main, but do something does not. It lives in the static context of string helper. So that's why this line worked. I'm sorry, this line did not work. This line did work. Now, my argument would be you would never need to worry about this if you always called your static methods using the name of the class in which they were defined. This guy was defined inside of string helper. This guy was defined inside of main. And I'm going to specify exactly where they were called by using the name of the class in which they were defined. All right, but that's why it didn't work. It's because it couldn't find it in the places it knew to look. It knew to look locally and then in the context where he currently lives, which is the other static stuff. But we are seeing with Java, so this kind of is the point, and hopefully this continues to reinforce the choice for C++ in that first class. C++ was meant to frustrate us in the first class. It was meant to not do anything extra for us in the first class, so that now we're appreciating the things that it does do for us. But now in this example, well, in the example I showed a minute ago, where I could actually say sh1.do something, and even though this is a class method, I am calling it with an instance and it's working. Java, we could say, there's a deeper explanation than this, but Java is effectively figuring it out. It figures out what you meant and it goes and does it. But that isn't necessarily consistent, right? We saw when we looked at strings a couple of classes ago, and when we're asking if one string is equivalent to another string and we want to use the double equal sign, we said, hey, most of the time we probably mean to compare the contents of the string, but we saw that that's not how Java works. So I'd make the argument that in some cases Java does too much for us, or probably because we had one programmer working on one part of the language and they decided to add some conveniences, and another programmer working on a different part of the language decided not to add those, certain conveniences that maybe would have made sense through a similar logic, puzzle. We're stuck with a tool that consistently works for that core group of things and does do some things consistently that are kind of life improvement types of things. But then we also need to kind of learn the nuances of that language to decide, okay, well, how does it actually differ a little bit from the stuff that's happens in other languages. So I think I mentioned, like in C#, you can compare strings using the double equal sign, and it works. It works the way we want it to work. Python works the way we want it to work. We even saw last semester in C++, very old language, but we were using a much newer string library from namespace standard, and the double equal sign worked in C++. So that might be an example. We might say, well, C++ being this old fogey of a language, string comparison worked the way we wanted it to work there. Java couldn't just step up. And what's even funnier is, Java's in version, I think 9 now, with a zillion iterations in between. So, I mean, Java's been out since, I don't know, 93, couple of minutes. Maybe they kind of could have snuck that in there. Just decided to, coming soon to version 10, compare strings to each other more conveniently. But then what will be funny is in another class, when I go and teach this, and I try to do the thing with 2 equal signs, like, see how this is false, and it'll end up being true. I'm like, oh, they changed it. And then I look like an idiot, and I have to say I did it on purpose, and all those things. So again, this idea that, programming is the skill set, the language doesn't matter. I still stand by that because we learn those core concepts of computer programming, but every language does have its little bit of a personality, and we sometimes need to stumble upon some of those nuances. Go ahead. So yeah, so I see what you're saying. So and you want it to stay static, right? Okay, so if it's static, it's called do something with param, and we had this guy take in an int a. We didn't need to define an instance here. What your parameter is here doesn't necessarily have to relate to anything else with the state of string helper. We might say that, okay, this function is kind of a waste of time. Like, why are we writing this function? We're writing it for an example, right? But it doesn't actually reflect on the string that string helper is managing. The idea is that most methods that live inside of string helper likely will operate on the fields of string helper, but they don't have to. We can write a function like this, do something with param, take in a parameter, and then just use that directly. No problem. So we come back out here. And this guy's expecting an integer, so we'll give it a 5. And there's my do something with param. It took in that value and just used it. But I didn't have to give myself a variable to work with. Now, similarly, even though we can say sh1 dot do something with param 7, even though we'll see that this guy will still work for the same reason it worked a few minutes ago, because Java just made it, allowed you to find this static method. It figured out that, oh, this guy is an instance of the string helper class. You're calling this method, which is a method that lives inside of the string helper class. It happens to be a class method, so we'll just go ahead and call it from a static context, but we figured out that you meant string helper here because that's what that guy is. It just kind of made it work. It connected the dots for you. That'll still work for the same reason it worked before. Is that what you were asking? Okay. Similarly, let's take it just one step further. I could take in a parameter here and just choose not to use it. It's a waste of time, but I can just say, hey, this guy takes 7 parameters and I'm just going to ignore them. It'll still work fine. It just, that 5 and 7 is just going to go into dust. We didn't actually use them for anything, but hey, they were still required, even though I'm not using it. If I don't pass this guy a 7, he said he expected an int. He's going to scream at me and say, hey, give me an int. I'm going to ignore it, but I need it. Make sense? That's how we define that method. We wrote it and said, this is what I require to do my job. All right. Now, if we're thinking about our string helper, this class, and we ask ourselves, well, why did I write this class? Why did I create this object? Well, we decided, you know what, there might be things that we want to be able to do to strings consistently, often. So we might want to create a class, this wrapper class, string helper, that takes in a string and then allows us to call some abilities on that string. So with that in mind, things like do something with params, those things probably don't make a whole lot of sense. So we'll get rid of those. And we're going to say, okay, here's my string helper. I'm going to build this guy. Here's my constructor. I'm going to build him with a string, and then I'm going to provide it with some abilities of things we might want to do to strings, something like that. Okay. Now, since these functions are going to operate on the field owned by this class, we're probably going to make these functions instance functions, non-static functions. Because when we call print reverse, I'll go ahead and guys. When we call print reverse using sh1, we want it to operate on hello. When we call print reverse, that same logic, the same method, we wrote that method once, but when we call it with this guy, we want it to operate on the field that sh2 owns, which is elephant. All right, so we wrote print reverse as an instance method, so it had access to the instance fields, the things that are in the instance context of this particular instance of string helper rather than the class. All right, so with that in mind, if I said string helper dot print reverse, what do I expect the answer to be? What does print reverse do? Let's comment this out for a second. I should have hello in reverse and elephant reverse before that, right? So that's what print reverse does. It takes whatever the string that is owned by that instance and prints it in reverse 1 character per line. That's what that method does. So we saw that we can call non-static or class, we saw that we can call static methods or class methods using the class name or using an instance name. We saw we can interchange that. Java just figured out what class we meant. Can we go the other direction? Can we call instance methods using the class name? Well, let me start off by asking the question, what do you expect the result of this to be? We knew the result of this first one should be hello in reverse. We knew the second one should be elephant in reverse. What would we expect the output for this to be? before we take a guess at whether or not it's going to work. It definitely worked the other way, right? I could call static methods using an instance method, and Java kind of just said, oh, you mean the class. It's a class thing. I'll figure out what class you meant by the instance you gave me. I'll find out what kind of animal that is, and I'll use that class. But will it work the other direction? What would we reasonably expect the output to be here, given what we know print reverse does? It doesn't make sense, right? Like, I'm printing the reverse of what? You gave me nothing, right? String helper doesn't have a string field associated with it. Print reverse cannot be referenced from a static context. Because I'm calling it with a class, the class name, I'm trying to call this non-static method from a static context. And as a human being, we decided, you know what, if I were trying to determine what you meant by that, that's kind of too vague for me. So I'm going to have an error. Where a human being who says, let's just assume print reverse was an instance or was a static method, or we had the do something function over there. You know, that actually was a static method, so we should call it with the class name, but we saw that we could call it with an instance and it still worked. As a human being, if we look at this and say, okay, well, what kind of animal is this guy? He's a method. How do we know he's a method? Well, we have the opening closing parentheses there. Great. What kind of method is he? Is he a static method or is he a non-static method? If you remember, we took it out of there now, but we had it written as a static method. Okay, so he's a static method. How do we call static methods? Well, we're supposed to call them with the name of the class in which that method was defined. But this dude's trying to call it with an instance of the class. Do I scream at him? Or is it reasonable for a human being to say, okay, I get what you're saying. You know, the SH1, it's one of these dudes. I'll just go ahead and do you a solid, and I'll just pretend like you said that. I'm not sure I agree with that choice from a programming perspective. Typically, we want programming languages to be fairly discrete, and we expect them. I know you don't like it when it screams at you, but you'll get that trained out of you when you'll stop making as many of those kinds of mistakes by being trained not to do it when it screams at you, right? But I don't know that it's completely unreasonable to say, look, Java, just figure out what I meant. You know, do what I mean, not what I say. You know, human beings do that all the time, right? You know, we just kind of read between the lines and figure it out. So I could say, okay, maybe that made some sense. But if we were asking, how could this make any sense? If you were talking to another person and they had the ability to print reverse and they called that, like, look, just print reverse. You're like, what do you mean? What? I don't have the tools. Or let's say, you knew how to add two numbers. And I say, 5 and 2, you spit out 7. And then I just walk up to you again and said, add numbers. What numbers? What numbers do you want me to add? Yeah, I'm not giving you anything. You add, you better get it right, is the punchline. All right, so, it's not a two-way street there. So back inside of string helper here, the idea is that we might have functions that we might want to perform on strings, common things we might want to do. So we might want to print a string in reverse. Similarly, maybe we want to have a non-static method, that is an instance method that already knows about the fields of this class. So this guy would be called with an instance of the class, not the class name itself. And maybe reverse string, instead of printing stuff out, reverse string actually returns a string that is this field in reverse. So I would probably create an empty string, something to build my string up and reverse in. Then I'd write my for loop that starts at the end of the string. So for I is equal to this dot the string dot length -1. So I'll start at the last legal position in my string. I'm going to keep going as long as I is greater than or equal to 0. And I'll subtract 1 from I each time. And what am I going to do? I'm going to say answer is equal to whatever answer is currently equal to, concatenated with this dot the string dot char at I. Okay. Now, did I need this dot here? I didn't necessarily need this dot here. If I leave it out, remember, all variables resolve to their most local definition. All right. So if I just say the string, when this code runs, Java is going to say, okay, where is the string defined? It's going to first look in this local scope, and it's not going to find it in there. Then it's going to look in the next best place, the next place it knows to check, and it's going to jump up and it's going to find it right here. So he'll find it. He'll stumble upon it. All right. But what if, just because I'm a jerk, I just happen to define a local variable called the string, but this guy is an int, which is going to be the double whammy for us, right? Because an int is a primitive type. And what differentiates primitive types from object types? Yeah. Primitive types can only hold a value. Okay. So right off the bat, I'm saying, okay, here's a variable, the string. Java's going to say, okay, that's a variable. I need to resolve it. I need to figure out what its value is. So it's going to say, well, let's check in my local neighborhood here. Do I find the string there? Ah, I do. So this guy is actually, he gets resolved to a -4. Okay. Primitive type. Good luck with that. -4 dot char at I. So not only are you not allowed to call functions on primitive types, I don't think it would make any sense even if we could, right? That doesn't mean anything when it comes to integers. But if I said this dot the string dot char at I, this would still work. So this would function the way we intended. Even though we have a local variable here of a whole different type, didn't have to be a different type. I just made it a different type to really emphasize the situation here. Even though I have a variable called the string defined here, I told Java where to find the string that I care about here. Look at your fields, the fields owned by this particular instance. That's the guy I'm talking about. Same reason as we did this with our constructors. Constructor took in a local variable called the string. When we just say the string, it's going to check in the local neighborhood first, and it'll find this guy. But in order to set our global the string, the instance field, the string equal to the guy that was passed in, we had to tell it where to find the actual variable we mean for you to set here. So we use the this keyword to do that. Right. My argument is never force yourself to have to decide whether you need it or don't need it. Always put it. If you're talking about the field owned by the class, always say this dot whatever the field name is. Don't rely on, oh, well, Java doesn't need it, so I just won't write it. All right. And some of you had comments like that on maybe your homework assignment, because I still see, as many times as I've talked about it, I still see people who will write your for loops like that without the curly braces. Now that'll still work, but it just accidentally still works because technically the syntax for a loop is it'll do whatever's in the next statement. So you can have a block statement, which is a collection of 0 or more statements, or you can have a single statement like this. You are never wrong to always use a block statement, even if you're going to put only one single thing inside of it. So even though you could choose to say, I'm just not going to write the curly braces because I don't have to, I would make the argument that you always should still write it. It makes you less error prone. I think it makes the code easier to read, all sorts of things. And it'll make you deal with less error messages. If you just get into the habit of saying, I'm not going to try to determine whether or not I need it. I'm never going to ask you a question along the lines of, do you actually need this keyword here, or would it function normally anyways? Okay, those are kind of like, I guess, trick questions, and I don't know that that's all that important. At the end of the day, you probably should know the rationale, whether or not it's actually necessary. But I would still say always use it. So I'm never going to ask you a question like that. All right, so our example here in reverse string is we're not printing anything. We could print stuff if we wanted to, but the idea here is we will ask a string builder or a string helper, we will ask him to give us the string that he is managing in reverse. So we will give ourselves a empty string to build our answer up in. We will walk our field from end to beginning. Each time through, we will tack on a character to our answer. When all is said and done, we'll just return the answer. So now my string helper has two different abilities. We have a print reverse and we have a reverse string. We know how to do two different things. So I'll say sh1 dot reverse string. What's the output of this program going to be? Don't guess, but read it. What is this guy going to do? Prints hello in reverse, one character at a time. What's this guy going to do? Elephant in reverse, one character at a time. What does this guy do? He's going to boil down to oh yeah. I'll write it like this. He'll boil down to OLLEH. That's what he'll return. So this guy ultimately will become this string. What am I doing with that string? Yeah, I'm not doing anything with it. So the output of my program, now is this an error? This will run. I don't have to do anything with the variables that I'm, with the values that I'm returning. Kind of a waste of time. Still ran, but after elephant was printed in reverse and we hit this line ran, but I didn't do anything with the value. Kind of like you're taking an exam, you hand it in, teacher immediately throws it in the garbage can. It's like, not going to do anything with that. Okay. So what are some things I could do? I could store it in a variable, which also wouldn't give me the output, right? I could print it out. I could choose to go ahead and just display whatever that guy boiled down to. So there's my hello in reverse. If I called it with a different instance, I would get elephant reverse. Make sense? All right. So we gave another ability inside of string helper to reverse a string. Now, like that. What do you think the output of this program is going to be? Go ahead. preceded by all the other stuff it was before, right? Okay, so when I print out sh2, even though sh2 was built using this string, it was built using the new keyword, which goes and finds memory for us. So when I print out sh2, what it's actually going to print out is the memory address where that guy lives. Which from Java's perspective is really just for show, because Java doesn't give us a syntax for working with memory addresses. So this is more just evidence that we have memory addresses. All right. Well, what if I don't want the memory address? What if I want the value that this guy was built with? I made this private. What did it mean for something to be private when we talked about it in C++? We had public, private, and protected. So what is a function that's private or a field that's private? What does that mean? Go ahead. Yeah, private means you only have access to this guy if you are inside of the class called string helper. So I might want to do that. I might want to say sh2, give me the value of your variable called the string. It doesn't have static in front of it, so I need an instance to call upon this guy, right? Okay. But Java's going to scream at us and say, hey, whoa. Yes, this guy is a non-static field. As a non-static field, if you were allowed to call it, you would call it this way. But it's a private field. And because it's private, we've set the security of this guy to only be accessible inside of a class called string helper. It's worked the same way in C++. So if we try to run this, it's going to say that this variable is not accessible from inside of a class called main. Has private access in string helper. So we cannot access that inside of main. Now, a lazy programmer might say, I got a fix for that. There we go. You didn't like it being private? Now it's not. Maybe not the end of the world in this little example. Now it'll work. So there we got our answer. All right. So right off the bat, notice it doesn't actually change that internal value when we reversed it. When we reversed this, it created a new string that it returned, right? Create a brand new string that it returned. But if we didn't want to, sell our soul, we wanted to be a good programmer where we make all the fields private, and if somebody were to have direct access to it, because by making this guy non-private, I could say sh2.theString is equal to woot, something like that. I could directly change the value from what that guy was originally constructed with. So now I've modified that object, which might not necessarily be the end of the world, depending on what you intend for your code to do. But chances are, if you built sh2 using this string, if that's what you needed to construct it, you probably don't want just anybody running around making changes to the internal workings of your object without at least some level of oversight. So we can provide that oversight by making stuff private inside. And then maybe we have a function here. Called get the string that just returns this dot the string. So we give ourselves a function that's accessible. We can make it public if we want, or if we don't put public in front of it, it's what's called package level security in here, which means it's accessible to anything that's in the same folder. But we'll make it public. It's called get the string. It returns a string, and it's just going to spit out the string. The string is private. Therefore, it's only accessible inside of a class called string helper. I happen to be inside of a class called string helper right here. So I do have access to this value. So now I'll just call this new method I wrote that I happen to call get the string. And this guy will now allow me to get that private field, but read only. I only know how to get that value. I can't say sh.sh2 dot get the string equals woot. You might be tempted to do something like that, but that doesn't work for what reason? Well, we have to ask ourselves, what does this boil down to? How will that resolve? That's what Java is going to do. That's what any programming language is going to do. It's going to resolve a field. This is going to boil down to elephant. So really what I'm saying here is, oh, try to change the elephant string literal to the woot string literal. That's the same thing as changing a 5 to be equal to a 6. Or reinventing something that's already a permanent literal. All right. For your homework, we'll start with very easy version of this. You wrote this in C++. Create a class called fraction that manages two private variables, two private fields, numerator and denominator. Write a constructor, write a method called display, which displays the fraction, write a non-static method called display, which displays the fraction in a reasonable way. Maybe something like 1/2, 3/4, something like that. All right, that's all you have to do initially. You're going to create your own class. It's going to manage two things. Right now, our string builder thing, or whatever we called it, it manages one thing. You're going to manage two things, and you're going to give it the ability to display. Make some sense? Yep, I'll put it up on Blackboard. Questions, comments, concerns, bribes? All right, I will see everybody on Friday.